Welcome to the future.
Welcome to the Muxall Open IoT channel. I am your host, Michael Crane. Alright, so next on our things to do list, let's see, finish this, is the flat flex connector for the LCD. And I was kind of looking at this. Is it me, or is this the hardest drawing in the world to read? It was drawn by Hishima Bukuro. I guess I'm probably not pronouncing that right. Sounds very Japanese. It looks like there's lots of Japanese hieroglyphics all over this drawing, which just kind of clutters the whole thing up. I don't know why they just don't have two different drawings, one in English and one in Japanese. Anyway, so I was trying to figure out what the footprint was, and by the way, they just don't give you a simple, footprint of what this thing should look like. They give you lots of pick and place information, which is fairly nice. You got 3 pages on that. But then we got just 2 pages on the connector information. So, and really only one, and it's this right here. Of course, it's 420 different, 16 different connectors. And look at this table right here. So not only do they put the headers on the bottom instead of the top, they alphabetically put it in backwards. So it's DCBA instead of ABCD. And of course, see, I would have flipped anyway. It looks completely backwards to me. So I was poking around, and of course, DipTrace doesn't have the exact pattern I want, so I found one that had a 0.5 pin pitch on it, and I'm going to kind of measure this out and hack it up and see if we can make our connector footprint out of it. So I'm not going to bore you with it. I'll show it to you when I'm done. Okay. Yeah, I think I'm done with this connector. Yeah, it took about an hour, I guess, to draw this up and decipher the Molex drawing. I think we'll call that good. And I'll delete all these dimensions. Unfortunately, you can't just hide them. That would be kind of nice just to hide them so you could come back and edit it later, but I think I tried that once upon a time and it didn't work. So, but anyway, I'll delete all these out and we'll be done. Then we'll put the connector on the main board. So here's what the connector actually looks like, and this is a nice 360 view. I was just looking at it, just doing a quick sanity check, make sure the drawing and the picture kind of line up. Looks like they do. Although this front area looks a lot different than on the drawing. And so it'll probably be okay. Let's look at this drawing here real quick. Yeah, see the drawing right here? It shows a long front snap-in handle, and the picture does not. So hopefully, I don't know if these pictures are representative of the real thing, but we'll see when we get it. Sometimes that's the sort of thing that'll cause lots of problems. You get it, the footprint doesn't work, or the part you want isn't the right thing. But we'll keep our fingers crossed, right? Okay, so I'm back on the main schematic here. And let me turn this grid off again. I'm going to go ahead and replace this with our new connector. Oh, I haven't created a component. I just created the footprint. Oh, I'll be right back. Hold on. Okay, so I created a new component. I just copied one of the other ones over to my custom library. I'm gonna go ahead and attach the change the pattern out. That looks okay to me. Oh, there we go. All right, let's go back. Let's save this. Now we can change it out. There, that looks better. Man, my snap is just not working. What is going on here? Oh. I'll be back. I need to figure out what's wrong with my snap. Okay. So I got the connector in there. I was moving some of this stuff around and I was looking at this guy right here. I was like, 2 microamps. That sounds very small for an LCD, and I pulled up the data sheet for the NHD LCD, and sure enough, its max draw is 2.0 microamps. Of course, that's not, the backlight's different, but that's on a different circuit over here. Here's the backlight stuff. But yeah, anyway, I thought that was kind of odd. Okay, so I pulled up the data sheet for the chip-on glass for the LCD, and yeah, I was right in suspecting that number seemed pretty low, because the chip that's driving the LCD it can pull a max of 650 microamps. So yeah, I'm not exactly sure what that number was that we were looking at earlier. Yeah, this two maybe. So anyway, even if it's 2 milliamps, it's still tiny, right? but yeah, I think I'll just change this to I'll just make that milliamps, and that should cover everything. All right. So one of the last things one of the things also on our things to do list is this add capacitor to the LCD power in. And it was just a bypass cap. I was going to add it somewhere around here for the 3.3 volts going into the flat flex connector. So I'm not really sure why. Well, I know I didn't add it, because if you look at the NHD schematic, I mean, they basically say, well, you can just type, straight from the processor, the microprocessor, right into power in, right? Nothing, no bypass caps needed. But let me see if I can find it in here. I read somewhere in here that it's a good idea, so I'll be right back. Okay, I found it. So this is on page 82, of course. And we're using the internal charge pump and a single VDD, which is the power in. And you can see they have a cap right here. And of course, we just looked at the NHD data sheet, and it doesn't. By the way, this is the Citronics data sheet, which is the chip on glass. And so So yeah, they're recommending a capacitor between power in and ground. And down here they say, okay, so capacitor VDD and VDD2, minimum of 1 microfarad. All right, it says higher capacitor values are recommended for ripple rejection. And so it doesn't really say what size they need to be. I don't know, maybe 4.7. That's a nice round number. I'm going to search around a little bit. If I see anything, I'll come back. Otherwise, we'll just go edit it here in a sec. Yeah, another thing too is there may be NHD added their own capacitor in here, but we don't know. And since their datasheet doesn't really say, I'm going to assume they didn't. Okay, well, I was just looking at the BOM of what other caps we have in here, and I guess we'll go with the 1 microfarad. We've got a 0.1, which, oh, that's that big power cap, line voltage cap, and 1000 puff, 0.02, and 10 mic. Yeah, so I guess we'll go with the Samsung cap. We're using them, using 13 of them so far, so we might as well make it 14. Okay, so I'm gonna copy that, paste. All right, well, there we go. All right, so C8. So I'm gonna add that to the BOM. Ooh. C7, C8. I think I need to update these numbers too. I believe they've changed. But I'll do that in a little bit. I'll export the BOM from the drawing and update all this stuff. All right. So I've been kind of sitting there thinking about this note where it says minimum of 1 microfarad and higher cap values are recommended. I don't really want to buy a 4.7 or something like that for just one-off cap, right? So I was looking, I do have these 10 microfarad caps that we're using for bypassing the ADC, and but they're 30 cents each, and versus 8 cents. But I think I'm gonna go ahead and do it. We're already getting some of these 10 mic caps. So I'm going to change this back. And yeah, so we'll just change that into a 10 mic. That'll be more than enough. Like I said, this thing didn't have any problems. It's been running just fine. So this is just gilding the lily a little bit. Okay, so I'm looking at our things to do list here. Let's see, we've added the flat flex connector. I'll flip it. I'll remember to flip it because I'll have to look at it, but I'll flip it on the PCB. So I'm going to go ahead and cross that out. And we added our capacitor to our LCD power in. All right. So that should be all the schematic changes that we need. The rest of them are in the PCB layout tool. Okay, so I've been staring at our PCB here, and of course we need to reduce if we make it not as wide, it needs to get reduced down to 57 millimeters. So basically cutting 7 millimeters off, it looks like. And if we, we also need to shorten it, right, to make room for the the 3.5 millimeter jacks and the power switch. So that's about 11 to 12 millimeters, which is about right here somewhere. I think these terminal blocks right here are 12 millimeters wide. So, and I've been literally staring at this for 30 minutes or more, trying to see what I can do to move everything up. And there's so many changes. We're gonna move these headers have to be moved around. Well, at least these down here do. Well, maybe not. Let's see. What do we got going on here? So that's for the bottom board, the power board. Let's see what's on the bottom here. Oh yeah, so yeah, these button headers are gonna have to be moved up. And I'll probably shift everything. So I guess what I'm getting at is I'm probably just going to lay all 3 boards out. Well, probably not the button panel. The button panel doesn't take a lot of changes, and it's pretty simple anyway, but I just need to move around the board-to-board connectors. But yeah, I think I'm just gonna start from scratch and relay this out. And I'm not gonna video it. I've done videos on this layout stuff and on all 3 boards, I think, and it's gonna take me guessing about 8 to 12 hours to lay out this board again, maybe longer, depending on if I run into any problems. It might not be too bad because I have all the footprints already, so that should be good. And I've done it before, so I've got a good idea. But another thing I want to do is I want to move some of these. This is the push button mounting holes, and it's that push button's right over the. You can see here's the outline for the push button right here, and you can see it's right over these pins, and I have it sitting above the pins, and I kind of shaved the pins down a little bit, or clipped them down with my clippers. But you know, if something smashes into that button real hard, it's going to short it out because it's metal on the bottom of this push button. So yeah, I think I'm going to try to move this ESP board somewhere else. So that push button's not going to short anything out. We'll see. I don't know. It's going to start getting pretty cozy on that board. So but anyway, yeah, let me get started. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button. That really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.